Section 7.2, Properties of Exponential Functions. The objective today is to explore the properties of functions of the form y equals a b to the x, and also to graph exponential functions that have a base of e. The factor a in ab to the x can stretch or compress, and possibly reflect the graph of the parent function y equals b to the x. So we're going to investigate which numbers do what. For the graph of y equals 3 times 2 to the x, each y value is 3 times bigger compared to that of the parent function y equals 2 to the x. So this 3 out here is going to stretch the graph by 3. For the graph of y equals negative 1/3 to the x, each y value is negative 1/3 times as big as the corresponding value of the parent function. It also reflects across the x-axis. So here, the reflection takes place with the negative, and this being a fraction, that is a compression. So when it's a whole number bigger than 1, it stretches, and when it's a fraction, it compresses. Here's a couple of formulas that you might want to write down. One is that of the horizontal shift, y equals ab to the x minus h. So remember that this right here will translate this either right or left, depending on if it's a plus or a minus. It's the same as a vertical stretch or compression, ab to the negative k times b to the x. Right here, what you're thinking is x minus h equals 0, x equals h. So when it's minus, it will be shifted to the right. If it's plus, it will be shifted to the left. So it's opposite of what you might think. A vertical shift, y equals ab to the x plus k, shifts to the right. Or wait, sorry, up k units. And it shifts it from the vertical shift from y equals 0 to y equals k. So it does bring that whole line up with it. So for the next two, how does the graph of each function compare to the graph of the parent function? Describe it. So with this one, the parent function is y equals 2 to the x. Notice this is the part that really changes it. If we look at that horizontal shift function from before, it says that this one, x minus 4 equals 0, x equals 4, would be 4 units to the right. The asymptote would be y equals 0. The y-intercept becomes 1/16. And if you investigate when those are, when you plug numbers in, that's where you get those numbers from. The second one, we are multiplying this whole function times 20. Notice also that it's a fraction to the x power. This right here moves it up 10. If it was minus, it would go down 10. This time the y-intercept becomes 30. And remember, that's when you're looking at plugging a 0 in for the x. What is the y? If you plug a 0 in there, you get 20 times 1/2 to the 0 plus 10, which is 20 times 1 plus 10, which gives you 30. The range stays y is greater than 10. It was y is greater than 0 before. Oops, I wrote 0. Y is greater than 10. The domain does not change. So the plus 10 moves it up. If it's in parentheses as the exponent, that would be right or left. Families of exponential function, y equals b to the x, y equals ab to the x. It's a stretch if the absolute value of a is bigger than 1. So here we're talking about numbers like 1, 1.5, 2, 2.5, those kinds of numbers. It's a compression if it's a fraction between 0 and 1. It's not just a fraction. Make sure that fraction is between 0 and 1. And it's a reflection if you have a negative number ahead of that x. The translations occur in the exponents. So there's a horizontal translation by h, which is the right and left movement, and the vertical movement by k, which is up if k is positive, and down if k is negative. Y equals ab to the x minus h plus k if you have all transformations combined together. We do have another formula, and you guys will not have to memorize this one. You'll have the formula. You will have to know what these stand for. So know what variables stand for. So when I give this formula to you, I will have A of t equals PE to the RT. You will have to know what these all mean. So in this one, A of t is the amount in the account at time t. And this is for continuously compounded interest. The P is the principal, that's how much you're putting in there. The R is the interest rate, and that's an annual rate. And the T is the time in years. So suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. How much will you have in the account when you enter high school 4 years later? So A of 4 equals 3,000. E, your rate is 0.05. You do have to change that to a decimal. And we are looking at A4. So we're going to type this in our calculators. 3,000 E raised to, put this in parentheses, 0.05 times 4. Your answer is $3,664.21. If you needed to know how much interest you'd get, you would take $36.64.21 and subtract what you put in there to get $664.21. So that would be the interest that was earned. You'll notice that in the book, they say round to the nearest dollar, in which case this would be $3,664. If they don't say round, just go to the nearest cent. Here's some got it questions. Why don't you practice each one of these, and then you can refer to the video. You can pause it, refer to the video to see if you got the answer correct. So with this question number 1, how does the graph of the function compare to the graph of the parent function? Your parent function is y equals 0.25 to the x power. So we have to look at the numbers that make this one different than the original. This number right here causes it to be a stretch of 5 units. And this number right here causes it to go up 5 units. Read and practice problem number 2, and you can refer back to it when you're done. About how much will be in the account for problem 5 after 4 years of high school. Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. How much will you have in the account when you enter high school 4 years later? So with this one, we did the example $3,000 and 4 years later. We want to do 4 years after that. So you can do this problem a couple different ways. You could use the answer that we just got up here, which was 3,664. So A of 4 years, 3664 would be the starting principal, e to the 0.05, and then we're going to do this 4 more years. Or you can start with what you did at the beginning and do 8 years. So at the beginning, we deposited $3,000 and it's going to stay in there for 8 years. So you're going to do 4 years of middle school and then 4 years of high school. So we're going to change this to an 8. If you calculate each one of these and round to the nearest whole number, you get about $4,475 each time, and you can stop and check that. So either way is okay. If this was actually a problem from the beginning, we would use this one, but if they ask you 2 different questions, you could use the one before it. So make sure you've taken as many notes as you want to. Bring questions with you tomorrow, and we can answer those as you guys work some of the problems in class.